Hi, Earth scientists. This is Unit 2, Week 3 on our study of weather in the atmosphere. And this is your weekly overview to help you get started. We're starting the week off with a discussion looking at, does Earth ever lose or gain anything? How much does Earth weigh? Does Earth ever need to go on a diet? Does it ever lose anything, like those helium balloons that are released into the air, which I hope you don't do because that's bad for the environment. So post your discussions below and make sure that your posts are about a paragraph in length if you want to receive full credit. So next we're continuing with how Earth's weight and how does Earth gain weight or not gain weight. So take a look at this video and see what you think. There's your learning targets for the week. So we're basically focused on a couple different things related to the atmosphere and learning how to read some charts related to weather and human activities and how human activities will impact weather in the atmosphere. Check out this video to learn a little bit about meteorologists and how they study our weather and our climate over time. And this also relates to that, how meteorologists get a better understanding of our weather and how technology is used to help meteorologists and scientists to predict weather. So make sure you check out that video. Next, we're doing a little activity to track the weather. So after you have watched those couple of videos to learn about technology used to study the weather and how meteorologists learn that information, then you're going to track the weather over a couple of days. So you're just going to collect data over 3 days, and you will need to, in your data table, input the information for temperatures in Celsius. So in order to do that, if you have the Fahrenheit temperature, then you'll need to convert that. So this is how you do that right here. And you also, depending on your weather source, may be given the data in Celsius and may not have to convert it. So it just depends on the source. So if you click on the document here, this will pull up your guide and help you to sort of walk through that process so that you can see what all you need to include in your weather tracking. So you're putting your dates sort of across the top here, and then you're including temperature, humidity, wind speed, and a bunch of other factors that are related to local weather in the area. And you're just doing that over 3 days to track the weather, and then you are analyzing that data and then making some predictions. And then make sure that you submit that in Canvas so that you can get credit. After you have done that, take a look at your online notebook, and this is what it looks like for Unit 2, Week 3. Your reflection paragraph that you're starting off with here is a reference to how much does Earth weigh, looking at the videos and the prompts earlier that we had just looked at. Make sure your paragraph is a paragraph. And then you are taking some notes. So your notes are related to the video, what's the fix. So it's 2-column notes. So you're putting main ideas and then specific details on the right-hand side. And then you're listing some important notes over here, referring to some of the videos and the information that you have learned through the text. So again, 2-column notes, make sure you put the main points here and then detailed information on the right-hand side. You should have at least 7 notes, but feel free to take as much notes as you want to. The more information that you record, the better for your own learning, of course. So how does water vapor influence weather? This is related to cloud formation and humidity. So humidity is just referring to the amount of moisture that's in the air, and that is related to temperature. So the higher the temperature, the more water, the more moisture that you can have in the air. So if you have 100% humidity, 100% relative humidity, that means that the air is holding as much water as it can at that particular temperature. So clouds also form because of water vapor. So we know clouds are made when water vapor, which is water as a gas, when it cools down around particulate matter, dust and smoke particles and stuff that's in the air that will serve for condensation nuclei for basically the water vapor to cling onto as it is cooling down. So if you've got a lot of water in the air, then you can have a lot of clouds. So this is a relative humidity chart, and this is really easy to read. So this is an application skill. So the example that I give you here is that at 80 degrees and 100% humidity, the temperature, the heat index is 87 degrees. So when you hear heat index, when you're watching the weather, then that's what it's referring to. So here's your temperature on the top, and then your percent of relative humidity here. So at 80 degrees Fahrenheit, if you look down to the example of 100% humidity, 80 degrees right here, 100% humidity, it feels like it's 87 outside. So if it were 94 degrees outside at 65% humidity, so there's 94, here's 65% humidity. If we scooch on over here where they intersect, it's going to feel like it's 114 outside, which is super hot. So those factors are related and make up the heat index. Acid rain is something we've talked about just a little bit. So when you have acid rain, this is going to be due to primarily the burning of fossil fuels and the releasing of this exhaust, these emissions, into the air. So when those nitrogen and sulfur-based compounds, the nitrous oxide and sulfur oxide compounds, get into the air, they will combine with water vapor that's in the air. So when they mix with that water vapor is when it becomes acidic. So the normal rainwater is going to be just slightly acidic usually. So water should be pH of 7, that's neutral, but normal rain is just slightly acidic. So when you have acid rain that's forming, it's going to be even lower. It's going to be in this range here, which is comparable to lemon juice. So that's why you have a picture of lemons here, because lemons have about that acidity of about 2 to 4 pH. And we do have acid rain that occurs here in North Carolina, and one of your videos in just a minute is going to be watching to see the effects of that. So here's a little discussion about acid rain to show me your knowledge about how air pollution can impact waterways as related to the burning of fossil fuels. If you need a little bit more information about acid rain, I've put a couple links here. This is an article, and then this is a video clip. So both of those will help you to have a better understanding of acid rain before you post your thoughts in the discussion. So this is an audio clip that's going to help you to better understand how human actions can have an impact on rain and can adjust the pH, so can change the level of acidity. So how do you think humans have an impact on the air? There's lots of different ways that we pollute the air. And unfortunately, human actions have severe impacts on air quality and water quality. So smoke from factories, burning of fossil fuels, coal, oil, and gas. Cigarette smoke also puts particulates into the air, exhaust from cars, exhaust from airplanes. So there's lots of different types of ways that we put different types of pollutants into the air. Aerosol spray is a big one because aerosols and refrigerants also are going to add chlorofluorocarbons, CFCs, into the air. And that is going to contribute to the depletion of the ozone layer. So this video is going to help you to have a better understanding about acid rain in the air and how the particulates that are released by human actions will have an impact on the level of acidity of our rain. Here's your lab for this week's module. Lab 11 is about air pollution. There's a couple different ways that you can complete this lab, and I tried to put a few suggestions here in case you don't have a Petri dish at home, which you probably do not. So a Petri dish, of course, is just a round, flat, clear dish. And it's going to be sort of small, about the interior of the palm of your hand. So if you don't have a Petri dish, then you can use a small, clear, like disposable plastic plate will work. A Tupperware lid, so you need something that's clear. The roundness of the dish doesn't matter. It can be rectangular. So if you have a small, clear, dish-like apparatus, that works just fine. Then you also need some Vaseline and a hand lens, magnifying glass. And if you don't have one at home, I'd be glad to lend you one of mine. So just stop by my classroom so that you can get one. If you want to work with someone at your school, if you are putting your particulate matter catcher at school, then that's fine. But each of you should be completing your own lab write-up. So the lab write-up here has information about how to do the lab, and I'll just show you this right here. So you're making a hypothesis about what you think air pollution looks like and the types of particulates that you think might be in the air, either around your home or your school, whichever it is that you choose as your testing location. You're going to need to set this up earlier in the week because you need to let it set and collect particulates over a couple of days. So basically, you just get your Petri dish or your Tupperware lid, and you're going to put just a small circle of petroleum jelly. It can be quarter size, 50-cent piece size. It can be larger. It doesn't matter. It just doesn't have to be huge, but it needs to be kind of in the center of the Petri dish. It doesn't have to be a super thick layer. It can just be a thin smear of Vaseline across the dish. So then just put some kind of sign or something up, particularly if it's at school or if you have, siblings that mess with stuff or whatever. Put something that says it's pollution collection or particulate matter collection, science in progress, whatever you want to say. And tell your people around that area. Like if you put it in the kitchen of your house, make sure your parents know that it's there for your science project so they don't throw it away because it needs, again, to set out for a couple of days. So just decide where you want to put that, and then if you're putting it at school, then clear it with, your teacher or whoever it is, wherever you put that particular matter catcher. And then you're going to make daily observations. And then after your 3 days have passed, then you can continue looking at your dish and see what kind of particulates that you find. So if you want to share your observations with, colleagues, friends, peers, classmates at school, that's fine. But you don't have to. It's completely optional. So you make a prediction. Where do you think you're going to find the pollutants? Where would you find the most pollutants if you decided to put it at school? Like, did you put it there because you thought you'd get a lot of pollutants, or did you put it at home because of that? Then day 1, day 2, and day 3, this is where you are going to attach pictures. So you need to take a few pictures of your particulate matter apparatus. So you just post a picture in these and make sure you put the location so I know where it is that you are collecting the particulates. And then for each of the days, write down what kind of things that you observe. And I put a little hint in here that depending on the location that you have your object, you may want to put a black sheet of paper when you do this observation part and you're looking at it with a hand lens. You may want to put a black sheet of paper underneath it because lighter color particulates will show up with the blacker background. And then you may want to alternately try a lighter sheet, like a white sheet of paper, underneath your dish so that you can see some of the darker particulates. It'll just let you see things a little bit differently, to have a little bit of a different perspective. So you're answering these analysis questions, and then make sure that you do the paragraph conclusion and then submit your lab. And then this is also tying in with your online notebook. So you have a little note here to make sure that you write this down or take notes from this. So here's a little video about mitigating effects of air pollution and what some possible solutions are. Here's one final post for you, a little text entry, looking at what can you do. So on a personal, individual level, what can you do about air pollution? What can you do about mitigating the human impacts of atmospheric pollution? And then when you're finished with all your assignments, make sure that you have submitted everything and take your quiz.